Good morning all of you. First of all, on behalf of Mechanical Engineering Department, I welcome our guest Professor Dinu, his colleague from the Romania University, all participants who has come from various corners of country. I just come to know that there are only 2 people from Gujarat, the rest of the people are from other states. So it's a matter of pleasure for us to welcome you all, and you can enjoy the lush green campus of SVNIT. This will be an opportunity for you to interact with many people of our department. You can visit various laboratories, may create an opportunity for the coordination for different activities jointly between your institute and our institute. So, I feel that this is an opportunity for all of us to join together for some academic activities. So far as this topic is concerned, he said that I had an earlier experience of MANTRA, Man-Made Textile Research Association. The basic aim of that institute was to develop textile yarns for various application, textile fibers for various application. And in the year 1990, UNDP has a great challenges that farmers were suffering for their jute product, because PP bags were very familiar and their crops was very difficult for to use it. At that era, I started to use jute, which is a natural fiber, for a value added product. So, we started a project to make a composite material for textile industry, and we nearly make 10-15 different products, and it was applied into the industry, so that we can say we have replaced wood, we have replaced plastic, we have replaced metals, we have replaced cast iron component, and all that components are seems to be a feasible, which can give you the replace the conventional material. So, from 1990 I had started to work in the area of composite material. Today I have chosen to talk on this topic, material characterization of shape memory hybrid composite. Then I have put the 2 sentences here, that is a case of composite modified with graphene nanoplatelets, and an importance of reverse engineering for measuring the shape memory. Before I go for the entire topic, first I would like to say what is the conclusion of my work. I go reverse way. You all know from all this lecture what is composite material. Mixing A with B will make you the composites. I say I take only resin material and add nanoparticles, it is 2-phase composites. Okay. Then we add a reinforcement either as a long fiber, short fiber, whatever may be fabric, that is a 3-phase composite. So, we may enter into the multi-phase area. Now, the importance of graphene particles is to make the interface area strong, and it is used for improving the property. So, first if I take a resin material and if I add the particles, 2-phase composite, property of that resin material gets improved. If I add additional fibers, fabric, anything mat, then that is a reinforcement added 3-phase composite. Ultimately, these particles are basically used to improve the property. So, we say hybrid composite. Now, constituents are added more and more, it becomes hybrid. Then I use this word, a case of composite, with this improvement, and second, the importance of reverse engineering for measuring shape memory characterization of that particular component. Say for a space people used to make a छाता ऊपर जाके खुल जाता है. So in a space if you want to make certain component and with the application of heat if you want to expand them, so if you want to make a change in the shape, then you need to select certain materials. That materials, resin materials, is you need to first ensure that it is sensible to what? Temperature, pressure, magnetic field, what? So here in our case normally we use resin with resin as a matrix material. If that resin or that matrix has a shape memory characterization, it has that capability to react with temperature or something, in that case we will consider that matrix as a shape memory polymer, and then we try to deform it to give a shape by raising its temperature around Tg, and then it is set. So there are two terms very important, that is fixity and recovery. Fixity means if there is a long strip, I want to bend it to 90 degree, then my fixation angle, at what angle it fixes, my programming angle is 90 degree, I wish to make it 90 degree, but when I apply it just like a metal strip, if you bend it for 90 degree and when you put up your punch up, spring back effect opens it, so instead of 90 you will get 92. So if I measure that angle, that is a fixity, means whatever is a program, are you going to get the same value or not, fixity. And second thing, when you again take it to a temperature Tg of that polymer, and if it tries to regain its shape, at that what is the recovery? So are you getting the same or not? So there are two terms which is very important in case of shape memory polymer, but when we add the nanoparticles, both these properties are hampered. When we add the reinforcement, again the property of shape memory is hampered, but in order to give the structural strength, we need to apply these two things, either this particle reinforcing particles or reinforcement material. I do not know what is. I will not discuss all this thing because from long time you are already knowing what is composites. So whatever may be the constituents you add, it can be n number of constituents, not only fiber, resin, but you can have so many components. Two terms I am talking. I think you might have seen that filament setup in Harshit laboratory. You take a thermoplastic in extruder, you add something, mix it and make a wire which we use for as a filament for your 3D printing. So it can be a thermoplastic. But if I take about the composites, normally the composites are having thermoset resins. So thermosets, the name is like this, plastic filled, we say reinforced plastics or a composite plastics. In that case it becomes thermoset resin. Now I do not know whether you have focus or not. In case of thermoplastic, by addition of all this thing, what will be the shrinkage of the material into the mold becomes very important. It depends upon so many properties of the materials. The requirement of materials, now you know why we need a composite material. Two terms, additives and fillers, these also you might have discussed, but one sentence I would like to say on this slide. Whatever you add into resin material, if it improves the property, then it is reinforcement, and if it reduces the cost of the material, it is a filler. Say on a concrete slab, what we are doing? Cement, sand, we add a steel. So, steel is used as a reinforcement, it improves the property. But instead of sand, if I use ash, it will reduce the cost. So, important statement, the function of additives is to reduce the cost, and reinforcement. Additive can be both the things, additive can be fillers as well as it can be reinforcement. All these points you might have already undergone this thing, but we know that the very important property of composite is tailor made design, and that is why I start with this. If you add one constituent of nano scale into the matrix material, then we say nano composite two phase. There is no reinforcement, there is no reinforcement. Now, the dimension, it may be 0 dimension, 1 dimension, 2 dimension, 3 dimension of nanoparticles, but the important point what you need to understand, one of the dimension is around 100 nanometers. So, if that is the thing, then why we use this? Because we would like to create the new material which may be applied for any application, because you are tailoring the material. So, you know for what purpose you are designing the material. So, fundamental concept for making the composite is to bring the new material, and it should have so many properties. So, basically you would like to improve the physical properties, or you want to target some specific application. Under the circumstances you will design it. Sometimes you can also have nano clay for nanoparticles. I may skip some of the things. You can have the nano composite either polymer based or non-polymer, means metal based also, ceramics based also. So, nanoparticles are mainly used for polymer and non-polymer, both the applications. You can have 0 dimension, 1 dimension, 2 dimension, 3 dimension. We can see some figures so that you will come to know. If it is a particle, we say 0 dimension. If it is cylinder, random, wire kind of thing, you have 1 dimension, you can say 1 dimension. 2 dimension, you have proper orientation, or 3 dimension, you can have particles, proper oriented wire, tubes, so and so things. Now, the important point of these small particles, the larger surface area. In UG, I used to teach subject mechanics of composite material. I will show that one slide also, how we calculate that things. So, this large surface area will enable better adhesion with matrix surface. So, the purpose of particles thinner, or similarly fiber also, thinner the fiber, better the strength. So, the surface area gets increased and better adhesion you can get. So, you get larger surface area in terms of particles. If you consider that, later on we will see, if I take 1 gram of nanoparticle of graphene, what is the spherical size of that particle? When I say nano, 10 raised to minus 9, okay. Then 4 pi r square, if I consider sphere. If there are lakhs of particles, or somebody say in 1 mole 6 point something into 10 raised to 23. So, if you make that, that makes a football ground. So, nanoparticles, if it is beyond certain limit, it creates a problem. So, you cannot go beyond certain limit. In some of this slide, I have put one word also, that we will see later on.
Sir, I have a question.
Yeah.
The particle which we are adding in the nano
particle strength it will not increase. Particles are laid on the interface. Particles are laid on the interface. In case of composite there is no alloying action. In case of composite there is no alloying action. Physical boundary will remain as it is. Even I can show you some SEM graph where you can see that on the interface the particles are existing over there. Only important thing for nanoparticles that they are to be spreaded over interface uniformly to give the best performance. And otherwise what will happen in case of composite material, there is a rich resin area. What does it mean? In that area reinforcement is less, so there is a chance of failure from that region. So similarly like this there is a term called agglomeration. Applications of this is to improve mechanical properties, thermomechanical, wear resistance, anti-corrosion, flame retardation. Many people are working on metal composites also with certain particles, boron carbide or something, for the tribological aspect. This we have seen, the dimension should be this. You can have the composite. Now lot of people are working with CNTs, graphenes. So the present work also I am taking with the help of graphene, two different kinds of graphene types. One is amine group and another is carboxyl group. So it can be a single tube or it can be multi-wall tube, that kind of reinforcements people are trying to make the composite for better properties. Now the representation of graphene is like this. It is a single layer with two dimension allotrope having a specific property which is responsible to improve the composite property. Similarly, fullerene is also used which will give you the 3D kind of things. So people are trying the research by addition of these kinds of materials. Epoxy we use as a matrix materials in normally making the composite. Majority of the publication you will see the resin materials are epoxy. Otherwise you can have vinyl ester, you can have polyester, you can have n number of things, urea formaldehyde, melamine formaldehyde, n number of resins are available. But if you see those who are working for aerospace and they want to achieve the good property, then they go for epoxy polymer because of it has so many meritorious points. The purpose is for using epoxy either for the adhesiveness or for the bonding. That is a separate area how we measure the bonding. I will take one case for pull out test later on, because if we consider how the epoxy has stick to the reinforced material, then how do we measure it? Normally sometimes we say nowadays the adhesive is one of the solution in day to day life. Earlier people used to have, if electric switch gets non-functional, a wireman used to repair it. Now nobody is repairing it, replacing it. So if something gets broken, even of metallic one, now you won't get a welder, gas welder, electric welder, isko pipe ko repair karo, not possible. People will say replace it. And if it is possible, you can have some adhesive to make that joint in a working condition. So the role of these kind of adhesive and polymers are very widely used for bonding purpose. Then epoxy based composite, where the fibers are bonded together in specific direction by polymer, we say epoxy, and they are mainly used for the high performance epoxy matrix composite. And if you consider this volume fraction, 10 to 60% is given from some of the reference, but if I use the text book, then in classroom we teach this fiber packing. You might be doing research, but again I am bringing you on a fundamental thing, that say if I work with cardboard, जो हम photo frame में पीछे use करते हैं ना, that is a jute particles with urea formaldehyde. Urea formaldehyde. Even if we take the case of our plywood, there are two kind of plywoods are available in the market. One we say commercial plywood, another is waterproof plywood. So if the wood veneers are bonded together with the help of urea formaldehyde, we say commercial plywood. and if the wood veneers are bonded with phenol formaldehyde, we say it is waterproof. The thing is, if you put the plywood sample into the boiling water for 72 hours, if all the layers are separated or there is a swelling in the material, we say it is a gone case. But if you take the phenol formaldehyde, you won't see that kind of failure. So, we say it is a waterproof. Now, when I talking to the fibers, if you consider the theoretical case, you may have arrangement like this or arrangement like this. So, this says that either for a square maximum 78.5% and in case of triangular 90.7%. तो आपको मार्केट में कोई बोलता है कि मैं कंपोजिट में 70% रीइंफोर्समेंट है, पॉसिबल ही नहीं. दिस इज हाइपोथेटिकल केस. When you say that, there is a no gap between them. Practically it is very difficult to attain that. So, the first earlier slide which says 60% is reasonable. So, that data has been taken from literatures, that people, those who are working on that, they have come to that conclusion that 60% it's okay, उसके ऊपर नहीं जा सकते. And if you try to make more than, then there may be a possibility some of the region may remain dry. That is also not advisable. So, these two figures are very important. Text says you can have 0.5 to 0.8 and these two arrangement say 78.5 and 90.7. So, this gives you an idea. This is a hypothetical case, otherwise in practical it is not possible. So, we can also have the epoxy based nanocomposite. You add nanoparticles into epoxy. Now, the use of carbon nanotubes, CNT and graphene is increased day by day, because the results obtained by various investigators are very useful and they are encouraging researchers to go into the depth. So, that more research is going with this kind of combination. Again, the graphene has a large surface area that helps in increasing the interfacial adhesion. Now, I may take the one case of pull out test, that if it is a single fiber, how we will test it. Again, I have taken this slide from my UG course, that how we calculate the interface area. So, we calculate the area of laminas like this, n into pi dl. So, based on that, if I replace the capital D by the small diameter, then this comes out to like this. So, the concluding remark is thinner the diameter, larger the interface area, and if interface is higher, then it will make the strong composite. So, basically if we want to make the composite stronger, then interface area should be increased, and that is why if you add the nanoparticles, then what will happen, that interface area increases tremendously, but people are using it 0.5, 1, 1.5, not more than that, because if you take it more than that, then it will not become possible to spread them uniformly and you may face the problem of agglomeration. It means एक जगह पे गट्ठा हो जाएगा and it is not desirable condition. For that, first I would like to show you the what is the time, you tell me. But time. Now, here also I will skip so many slides because ये 20 साल पहले का PPT है. In this slide I want to convey that the area where two constituents join is, the dimension is very less, 0, we say interface. alloying action is not taking place. But if that area becomes 3 dimensional, we say interface PHASE. This is a difference. Simple bonding है तो 2D है, but वो bonding interface create करता है 3D, then it is interface. So I think you have understood, if it is 2D interface, else it is interface. Now pull out test, मतलब जो फाइबर ने बॉन्डिंग किया है उसको मैं कैसे मेजर करूँगा? हाउ डू आई मेजर दैट, व्हाट इज द स्ट्रेंथ? So I just take one example, how do we carry out the pull out test? For that you can have wettability by chemical option, or this is a case of mechanical bonding. हम बाइक के हैंडल पे सरेशन क्यों होता है? Yes, so this is the same thing. You can have the peak and valley. So more surface area is subjected to roughing action. Sometimes you say the natural fibers are first washed and then treated with alkali. Then what will happen? The luster of that surface is removed. Now that surface become rough. So when you pour the resin, it penetrates into that, and therefore there is a mechanical locking. There is a mechanical locking which is a much more stronger sometimes as compared to chemical bonding. So there are so many things are there. One term you may be knowing, coupling agent. In this so many lectures you might have come across this term, coupling agent. If you want to improve the interface, then you use coupling agent. You can have a single fiber, you can have matrix. Now see, this is how we make a setup. This is PVC tube, these are the two supports, and this is a steel rod is inserted exactly in the center. Then we pour a resin material into it. Now what will happen? Outer cylinder resin, then this rod. Now if this rod is taken as a steel rod, whatever by default roughness is there, that is applicable by default. I am not making any treatment on it. So whatever surface roughness is there, you can measure it through telesurf. So those who are here, they know in metrology we measure the surface roughness by meteor telesurf. It gives us RA value. So you can measure the RA value. After this, I could not see, you can see the samples will look like this. This is resin and this is a rod. Now we make certain changes, parametric study. What we do that parametric study? The surface roughness 0.5 micron, 0.7 micron, 0.9 micron. How do I vary these? I take that steel rod on lathe and apply the emery paper. When apply the emery paper of different number, different grade, it has created me this value 0.5, 0.7, 0.9. Now thereby what will happen, that if I try to pull it, the resistance of different surface will be different. So the amount of force exhibited during that pull out test will be different. So it gives me an idea that if the roughness of fiber increases, then the force generated during pull out will be different. So first we will see the parametric things. Second thing, the length in which you apply it, कितने length में apply किया है. Then we test it into the rig. The specimen is kept over here. This is a rod. You use the tensiometer. So many of us is now aware about this equipment, and the test was carried out. This is separated one. So after separation, what we see this, the 0.5 micron roughness, I hope this is visible. So, you can see these jigs and it has broken here. Now, what does this mean stir? वो जैसे जैसे bond से टूटता है, it gives this value. So, for a 0.5 you will get these kind of pattern. At this value it is totally failed. Totally failed. So, this is a case of 0.5, then 0.7, then 0.9. Okay. So, जैसे जैसे वो बढ़ता जाता है वो वैल्यू बढ़ रहा है, उधर वाला वैल्यू. I have put in tables also 0.5, 0.7, 0.9. The load 235, 353, 431. See, resin वही है, steel वही है, fiber is same, matrix is same, but what you have done, the surface plays an vital role while you try to pull them. So, that is how you can increase the performance of the material. Then the next parameters we considered varying embedded length. So, this is a case of say 4, 7 and 10. Embedment 4 mm, 7 mm and 10 mm. Basically what we do, contact area is increased. So, more roughness area is provided. So, in the same logics you will see the results 7, 10, I might write table 39, 49, 58. It is quite logical. Okay. Now, what we have understood that in case of composite material you want to build, interface is very important, and what I show you is an example of interface. Okay. The same thing I make a model 3D quarter model, 1/4 model, okay. Then intentionally make a serration on it. Those who are familiar with CAD, what I do? I make a sweep, take triangular section and sweep on it. Then so many sweeps are carried out. जितने sweep ज़्यादा create करोगे उतना roughness बढ़ जाएगा. So, I try to simulate the roughness. So, when I try to simulate the roughness like this many number of cuts are there, and I used to put these 4 mm, 7 mm, 10 mm. Got the point? 4 mm, 7 mm, 10 mm. And then we try to simulate it different values 4, 7, 10, and the analysis gives you, we provide all boundary condition, everything is, all degree of freedom is restrained, and what will happen if you allow only to move in one direction. Forces are given. So, analysis was carried out and it gives you the stress value. Now, this can also be recorded, that if you change the roughness, what happens is, if you change the embedded length, what happens is, what we did physically. So, this is how the same case you can simulate also. So, I am not going into much more detail for this, but I have given you one idea that the tests can be carried out like this. Now, some of the literature gives me this idea, see this value, content. Maximum I can see 2.5, maximum I can see 2.5. So, as I said in earlier stage, you cannot go for inserting such a particles beyond certain limit. You need to verify it through your experimentation that when agglomeration starts. So, if agglomeration starts, instead of getting improvement, you will get the reverse result. So, that is not advisable. So, the limit you need to first identify, only within that limit you can use such nanoparticles for improvement, otherwise there is no meaning for that. Similarly, in some of the our work we notice that the Perstein, stretch and pressed and aligned CNT means if you see different stages, then you can observe the CNT which is taken as a SEM image. You can visualize that how it looks like in your specimen. So, that may be utilized for interpreting certain results. Similarly, whether your particles are uniformly spreaded or not, that can also be visualized either by TEM or SEM. So, these kind of characterization you can do. No, we have given this specimen to NIT Jaipur. They have good material characterization sample. So, one of my research student did this characterization exercise.
So, one small note is basically based on how the electron passes through a minute pool which we are making through the process.
Say we also have SAM over here. But if it is non-metal, then we used to make a gold coating on it.
I am asking for same procedure.
The same procedure. Coating is done. Now again, if you see this CNT, same thing, maximum to 6.5 for some of the cases, but normally you can see like this. So basically, the content of these particles are like this. Now, how we prepare the multi-phase nano composite? We use this acetone to dissolve the particles into, then we use magnetic stirrer, ultrasonification, vacuum chamber, degassing for that, add hardener, again stir it and use hand lap technique. So, thereby you can create the 3-phase carbon fiber composite by this process. Of course, we use a very layman technique, that is a hand layup technique for that, but process also makes a difference. Process also makes a difference. If you take the I do not know whether you are familiar with not Hilem, there is one company in Hyderabad which makes phenolics cotton composite, means the resin is phenolic and the fabric is cotton. They use fabric cotton. They take a layer like this, then wound like this, then wound like this, like this. Sometimes they take a rod, wound it, dip it into the phenolic and pass it to dye. So, the shape is created and that is known, that component is known as shuttle in a power loom. It is having very high strength. जिसने looms देखा है उसको पता है कि वो कैसे चलता है. So, it takes that kind of impact by Hilem materials, and even there is a wooden stick which apply on it tick continuously, and the life of that is around 3 to 4 months. You can imagine how many number of strokes, 120 strokes per minute, इतना फास्ट चलता है. That kind of impact is taken by that Hilem material. It is a trade name. Hilem is a trade name, but the process is phenolic resin with cotton fabric, not fiber.
So that is a reinforcement, right?
Yeah. But वो उसमें glass नहीं use होता है, carbon नहीं use होता है. They use cotton fabric. So this is a procedure for composites. Now, if you see that 0% means no addition, 0.4, 0.6, 0.8. What we observe in our some scholar did his PhD, So, after 0.6 he observed the decreasing trend for the property. So, beyond 0.6 there is no meaning to go for addition of the particles. The objective of the work carried out by my research scholar is development of polymer based shape memory material, adding nanomaterial and reinforcing fiber. In the beginning I say we use nanomaterial, we use reinforcing material. Both these additions are not advisable for shape memory, it degrades it. The polymer which is having a sensation for temperature exhibits a good as an individual, but when you add them, only the purpose is the component whatever you make out of that will get a rigidity, will get a good strength. So, if the product does not have a rigidity and strength, you cannot work for that product. So, first aspect is to make that product feasible. So, in order to make that product feasible with certain mechanical property, the reinforcement as well as the improvement in the property is achieved through the nanoparticles. So, all this thing at the cost of losing shape memory. As an individual polymer, it has certain property X, but by adding this it decreases.
Prof, I have two questions.
Yeah.
I'm very new to this field, so please excuse if they are very basic questions. Firstly, sir, what are the shape memory materials? That's the first question. The second question is the graphene that is being used. So is it 1D, 2D, 3D? What type of graphenes are usually being used?
I am using powder.
Powders. So powders would be
Particles.
0D.
Yeah.
That's the shape memory materials for
Epoxy. Certain grade of epoxies are having good sensation to temperature. So, you need to lift that temperature of the level of that Tg of that. So, at Tg it becomes softened and it is subjected to deformation. Now, you make a shape, change the shape, we will see some slides, will make you more clear. So, this is original shape, see original shape, heating, temperature increase, cooling, heating, again recovered the shape. Okay. So, this is the procedure. Now, this is the area transition where we say programming. Programming means what dimension we would like to change. My raw material may be flat strip, I want to bend it to 90 degree or 180 degree, or I would like to give a shape. See, my target is a 3D shape, still no very less work is done that. We have initiated and we have taken some of the samples. For that reverse engineering is very useful, because how you will measure it. So, I will show you some shape and you tell me how you will measure it. So, this is what we use: epoxy, shape memory, nano composite, then graphene is added, then I use carbon fiber. So, it becomes SMHC, shape memory hybrid composite. First 2 phase, this is 3 phase. Agreed? Concept is clear? Okay. So, when we take this, the shape memory properties in CFRP composites and specifically in 3D shapes, very rare literature is available. Second thing, when you add the nanoparticles, non-uniform dispersion of the nanofiller is an issue. How you will disperse them uniformly is a big issue. Second thing, we take the GNP nanoparticles with carboxyl and amine group. Preston, there are n number of options are available. People can try and characterize them and to observe the results, because this is also we did a pilot experimentation and we try to see that yes, there is something improvement. Similarly, we observe that while the programming stage, how the shape regaining is something different in by using different insertion. So, that was also good observation. So, if you want to go for all these things, I am having a facility of reverse engineering lab. So, we have needle scanner, we have laser scanner, we have immersion type of ferro arm scanner. All these things are being used to measure the shape change in the component. So we will see some of them here. So I use laser scanner and 90° deformed and flat, 180° deformed and flat. So my earlier object is a flat strip, I try to bend it for 90°, I try to bend it for 180°, and these dimensions are observed through laser scanning. Later on also, see, this is a flat one, this is 90°, again shape. See, programming stage, recovery stage. In the beginning I say somewhere two term RF, that is recovering fixity, and this is shape recovery. So shape fixity, shape recovery. So F means final dimension, F means final dimension, 0 original dimension, then this is recovered dimensions. So based on that, see here CAD model, this is point cloud data, and this is reverse engineering, which shows you the deformation from original CAD model. How does it differ, how much deviations is there. This is a flat specimen, you can measure it. This is a flat specimen, you can measure it, but the moment it becomes complicated like this, अभी कुछ नहीं measure हो सकता है. See this, this is surface, this is reverse engineering, somewhere you will see some deviations are there. This is the green means I have defined plus or minus 0.1, 0.1 means 100 micron, 100 micron को मैं allow करता हूँ, so that will be shown as a green line. Then whatever the things are changed, now see in a chamber there is a steam and I apply a force from these two direction, from these two direction, so the sample जो ऐसा था वो ऐसा हो गया, ठीक है. So I have given the name PS1, PS2, PS3, that is a programming stage 1, programming stage 2, programming stage 3, and here you can see at present everything is green. So whatever I have modeled कि ऐसा होगा, that has been attained within 0.1. Now see original stage, this is 3D printed filament, you have seen lot of setup now. So I took a specimen, spherical or parabolic, and then it is change in both the direction. Now in steam, how does it deform is not in my control. So this is preliminary experimentation, it forms like this, but when I try to recover, see their shape, this is not perfect, that one. So that is why I say fixity is different. आप जो फिक्स करना चाहते हैं वो हुआ या नहीं, कितना हुआ, यू कैन मेजर इट, एंड बाद में अगेन उसको टीजी पर ले जाइए, वो अपने आप उसका शेप चेंज करेगा, दैट इज रिकवरी. जो ओरिजिनल शेप था वो शेप रिगेन करेगा. सो नाउ यू सी वो शेप नहीं आया है. This is filament, 3D printed filament. या इन उसका जो आप फिलामेंट ले ली उसमें आ जाएगा ये. सो दैट इज व्हाई आई हैव शोन यू बोथ द थिंग्स, वो फिलामेंट में भी आता है. ये देखिए PLA फिलामेंट प्रिंट किया उसको फ्लैट, देन शेप मॉर्फिंग, आपने उसको बैंड कर दिया. ये बैंड कब किया? नो, यू हैव रेज दैट रीजन इनटू टीजी, टीजी में उसको रेज किया, अब उसका शेप चेंज हो गया. अभी आप उसको बाहर निकालोगे स्टीम चैम्बर से तो वो बैंड होगा, 90 डिग्री होगा. अब मैं क्या करूंगा, मुझे जब उसको खोलना है तो मैं वापिस उसको वो टेम्परेचर में ले जाऊंगा तो वो वापिस खुल जाएगा. तो ये जब शेप आ जाता है 90 डिग्री, दैट मीन्स इट इज अ फिक्सेशन. इफ आई हैव प्रोग्राम 90 डिग्री and if it is not 90 degree, it is 91, 92, that is the fixation error. But if it is a perfect 90 degree, say if it is perfect hypothetical case, and if I try to recover that shape again by raising the temperature Tg, and if it is not coming to 90, that is RR. recovery error. So, I think both the terms are very important. Okay. It may happen that in the beginning also you may not be able to attain the same shape, just like a metal, because of the spring back you are not getting the same shape. So, that can be one of the reason, whatever may be the reason it may be. Similarly, at the same time when you try to recover it, again you will not get the same shape, that is RR.
Sir, for recovery we just need to take it to the TG.
TG.
And that's it.
That's it. That's it. That's it. That's it.
For the initial stage we need
Again TG, but you need to maintain everything. Tool, डाई बनाइए, डाई बना दीजिए, हाँ हाँ, आप डाई पंच बना के उसको बैंड कर दीजिए, बट टेम्परेचर इज TG. फिर बाद में क्या कीजिए, जब आपने यूज कर लिया बाद में वापस उसको खोल देना है, तो TG में डाल दोगे, खुल जाएगा. हाँ, ओके ओके. Now you see, original program, original recovery, program in recovery. You can see this. ये shapes practically आप कोई tool से measure नहीं कर सकते. Very difficult.
How will it be done through the reverse engineering?
हाँ, तो आप स्कैनर में डाल के स्कैन कर सकते हैं. स्कैनर में आपके पास you will have a point cloud data. So point cloud data and programming model is with you. Okay. So it gives us that difference, and it gives you red, yellow, blue color also, that this is not green, this is ये तो blue हो गया पूरा, कहीं मिला ही नहीं उसको shape. That's a very dangerous thing. You are not getting your shape. So if you take any complex shape, or if you make a parametric surface, is a challenge. Bezier, you take a Bezier surface, it's a challenge. So you make a different change in the parameter and try to see it, it is very difficult to attain that.
In this case also the model for the actual deformation also is very important.
Yeah,
Even if we get that model right, we might.
correct. That is say original and programming. So I say RF. RF is also sometimes not possible to attain it. So that error will give you that even if you program, but you are not able to achieve it, you are not able to attain it. So that's an issue. Depends upon complexity of the object. Now at present I don't see any literature which addresses the nature of complexity. At present I don't see any literature. People say fundamental papers are available, that what will happen to shape memory polymer, shape memory alloy, shape memory composite, everything is there. But if that composite is Boeing body, say for example, तो क्या होगा? If it is a cuboid, if it is ellipsoid, then what will happen? How the shape makes a difference in two shape memory. So that kind of data is yet not available. Now we try to see the profile. अगर जिसको AutoCAD में करना है तो वो 2D में, see this is thing, see यहाँ पे ऊपर चला गया, यहाँ पे इधर चला गया, see this, see the complexity. इसमें हमारे पास कोई यार्ड स्टिक नहीं है, there is no yardstick how it has gone, unless and until you try with the known shape. जैसे मैंने rectangular box लिया, अब मैंने cylinder लिया, ठीक है, so known shape I can try and then I should try to increase the complexity. But here I have directly taken paraboloid and try to show you that how it goes.
So sir, if I take two identical samples and do identical loadings, I still might get different results, or I'm likely to get similar?
No idea, I have not tried. Because sometimes in a chamber it becomes very difficult to measure how much you have given. हमने तो यहाँ से air डाल दिया, इधर से दो निप्पल लगा के air डाल दिया, इधर से दो निप्पल लगा के air डाल दिया, कंट्रोल में नहीं है.
System conditions also.
हाँ, so you need to make a specific setup. If somebody wants to work on that, then he has to make a very setup which records every detail. Then it will be easy for you to conclude something. Otherwise it is very difficult. But this gives you an idea, this is an eye-opening thing. It shows that there is a vast work is pending. So those who are researcher, for them this is an area where they can work on it. Rest of the things you can see these section profile, circumferential profile changes. In a parabolic surface also you can have different changes. Then here we feel uncertainty also. PS2 में पैटर्न अलग है, सेम नहीं है, यहाँ पे पैटर्न सेम है, यहाँ पे पैटर्न सेम नहीं है. Programming stage, recovery stage pattern is also different. So you need to study it very thoroughly. Now what we measure the deviation, see this, minus 2-3% on this side, 2-3% on this side. So maximum 5% deviation what we plan, that is possible in this, 5% is okay. So you need to be ready with that if I go for this kind of thing, there may be a deviation. What is acceptance limit? Right now there is no standard available for this kind of study, there is no standards are available. So how can you say that I am okay or not? I cannot decide it. It is right now only trial and error. Unless and until if this gets standardized, then you will have some standard will say that 5-10% is acceptable, otherwise not acceptable. The same thing is explained over here, that graphene is added for the same experimentation 2D, and you can make the abrasive jet machining to cut the sample for characterization, tensile testing. Similarly for shape memory nano composites also, you can make the sample for tensile testing. Then shape memory hybrid costing, where you can have particles, you can have hand layup technique for making composite, and now this will become shape memory hybrid composite. What is an issue? In the beginning I have said the shape memory characterization is hampered by addition of both these things. Now you can see why all this thing, the stages what we have attained in 8 seconds. जो इसका shape recover होता है, that is in 8 seconds. The moment you put it into that chamber, in 8 seconds it becomes straightened. So by taking videos, all these points are being put up over here. We use these standards. Shape memory testing, हमारे पास कोई standard नहीं है. We don't have any standard. We simply take the video and then try to put the points. जी. You take any media, steam, we use steam. To
get to that temperature, you are using steam.
वैसे all these polymers are having their TG in the range of 80 to 110.
Yeah, it's like plastic.
Yeah.
100% the material will get the original position. There is any tolerance.
No, tolerance is an issue. Right now there is no guideline.
We are going real applications now, sir. The tolerance error also will make some issue now.
Yes, definitely. Yes, definitely. That is why I say right now there is no standard, and if it is your object is 3D, then what will happen? It is very difficult to judge. So the normally people are making sample, flat sample, and they go on making all this study. But I say that if your sample is now converted into product for real life component, and if it is having some shape, 3D surfaces, then how it will react is an challenging task to say right now. So what I did, I tried to make a paraboloid, and then I try to see what happens is. So that all uncertainties I have put up over here, that, and what observation I have put, that even in the programming stage you will not be able to fix it, which is very easy case for right angle. वो जो right angle में 90 perfect आता है, उसमें कोई problem नहीं है. But if it is having certain complex shape, then it becomes very difficult. We have not tried, but I think 3-4 के ऊपर normally plastics, thermoplastics, you can stretch it to anything, but when we talk to polymers, I think it is difficult. You can go up to certain cycles, still people can try for that, n times, 10 times they can try it. Here also you can see the comparison between 0.4, 0.6, 0.8 COH and carboxyl and amine. Normally amine gives better property, minutely, but gives better property. Even SEM will be able to show you if it is 0.4, 0.4, 0.6, then what will happen, somewhere you will see agglomeration, kahin pe wo gatta ho gaya hai. So that kind of things you can see, and the temperatures like this, you can see this is the range, storage modulus by DMA. Again same thing, 0.8 reduces, same 2D two phase, same observed for three phase also. Specimens are flat one, addition of particles. Same thing for load displacement curve, you can see different percentage what will happen. The pattern is same, that after 0.6 it is not advisable. Then this is a temperature 70, यहाँ से आपका shape change होता है. So he was asking about the plastics, then this is a region 70. Even if you take a hot water, it will work.
So these are amine based epoxy.
Amine based nanoparticles, but you can have a 0% graphene and you can work it. But you just go to the site of Sibatul. There are two companies producing epoxy. One is Ciba-Geigy and one is Sibatul. Ciba-Geigy is Goa and Sibatul is Atul, Valsad. So these two companies are, if you go to their website and try to see which epoxy is of these grade, that you need to select it. So that epoxy, or there are so many other polymers which are having these kind of characteristics, you can select them and try them. Even see, you can see 0% graphene, 0.4%, at the interface you will see that particles. 0.6 बड़ा हो गया, 0.8 agglomerate हो गया. So SEM gives you that kind of visualization, that how these particles are advisable or not advisable. Basically they build your interface. Now see here, these two formulas are written. I think कहीं पता नहीं, रेफरेंस में बहुत मुश्किल है, लिखना है तो लिख लीजिए. These two.
Sir, can you once again explain both of them for revision?
First, original 0 degree, final instead of 90, 91, final. Theta P programming 90.
Ideal.
हाँ, जो मैं 90 बनाना चाहता हूँ, I want to make it to 90. Theta P programming, this is again original. In case of recovery, final theta f minus theta, how much it is recovered now? Instead of 0 it is 2, so recovered. Theta f same thing, theta 0 original. So this is how you can see. यहाँ पे वही लिखा हुआ है, see, original stage, programming stage, recovery 1 second, 3 second, 9 second, what happens? If you see this 9 second first figure, not 0, not straight, what does it indicates? RR error. ये 90 में अगर ये perfect 90 नहीं है, if this is not perfect 90, this is wrong. Okay, so in real case both the errors are going to happen. Theta f may not be you are attaining, and theta r also may be possible. Okay, I think this has given you an idea that how the shape memory works on it, and with the help of this प्रोग्रामिंग स्टेज और ये रिकवरी में कितना डिफरेंस आता है वो आप देख सकते हैं बीच में. दिस ग्राफ इज वेरी इंपॉर्टेंट दैट इफ यू वांट टू स्टॉप इट समवेयर, हाँ, यू आप प्ले करना चाहते हैं कि मेरे को इसको इतना ही चाहिए, यू वांट टू डिजाइन सेंसर, इफ यू वांट टू डिजाइन सेंसर देन यू मस्ट नो दिस, 1 सेकेंड में वो यहाँ आ जाएगा, उसके बाद मुझे हीट को स्टॉप करना है, वो स्विच को जाके टच कर देगा. सो यू कैन डिजाइन अ सेंसर if you know these characterization of the material. Same thing for a graphene addition, what will happen to 0.4, 0.6, 0.8, Same thing with hybrid composite also. So for different materials, different characterization is being plotted over here. Again the SEM, somewhere it has been showed कि यहाँ पे void है, यहाँ पे damage है, यहाँ पे fiber rupture हुआ है, वहाँ पे void दिखा रहा है. So agglomeration में void is also available over there. Then same thing for adding this. If you add, what will happen? अब ये कर्व देखो, पहले वाला कर्व देखो, ये कर्व देखो. See, that smoothness is gone. That smoothness is gone. So I say that it hampers, but it is necessary. If you don't have a reinforcement or that particles, the stiffness to the component will not be attained. So both the things you have to come to some conclusion that what may be the best combination which will satisfy the need of the component feasibility, as well as you are gaining the shape also. So this is how it can be used. Now I will not go into the MMC part. So I hope I have conveyed the concept of shape memory, polymer, two-phase composite and hybrid composite. So if you have any question, you can ask me.
Sir, are there any places where this is actively being used that you know, this type of hybrid composites?
This is a pure academic research, but in a space the people are taking that unit to space and it gets open. छाता जो ऊपर खुल जाता है वो यही होता है. उसमें मिनिएचर हीटर लगी हुई होती है जिसको आप बैटरी से ऑपरेट करते हैं. वो इतना टेम्परेचर, अब तो आपको देखा होगा कि आप कश्मीर में जाओ तो बेड के ऊपर हीटर होता है. इवन आप जैकेट के अंदर हीटर्स आते हैं. सो स्मॉल पावर के ऊपर भी आप उसको हीट कर सकते हैं. तो आप उसको कंट्रोल कर सकते हैं, उसको कितना ओपन करना है, बंद करना है, दैट यू कैन डू इट. नहीं, हमने जो है वो सैंपल बना के उसका टेस्टिंग किया है कि बाय एडिशन ऑफ दिस व्हाट हैपेंस एंड रिकवरी में क्या प्रॉब्लम होता है वो ऑब्जर्व किया है. मतलब में पहले उसको सैंपल्स बिल्ड कर दिए बाय एडिशन ऑफ 2 phase 3 phase एंड देन व्हाट हैपेंस टू फिक्सिटी एंड रिकवरी, दैट वी हैव नोटेड. बट उसको दोबारा से वहाँ पे लाके फिर से नंबर साइकिल रिपीट नहीं किया एज ही आस्क how many number of side it gives. So that's a different area that somebody can do the same thing by taking only flat specimen. If I say I take n times recovery, what will happen? First time what happens, second times what happens, third time what happens, it's a different area. फिर से कहिए. नहीं क्रीप नहीं, वो that's a different area ना क्रीप. But this gives you an idea that you are not able to fix it, you are not able to get the same thing. Now what is an additional effort to be made? जैसे हम स्प्रिंग बैक इफेक्ट में क्या करते हैं कि अगर मुझे 90 डिग्री का मैं पंच बनाता हूँ और वो खुल के 90 हो जाता है तो मैं क्या करूँगा, पंच का डायमेंशन 88 करूँगा. ठीक है, मलिक एंड घोष का पूरा करेंगे हम इसमें प्रोग्रामिंग के, हाउ इट शुड कम टू 88.2. तो इसमें वो काम बाकी है. तो वही वो मैंने दिखाया, दिस एरिया ऑफ रिसर्च. कैड ज्योमेट्री में कोई गाइडलाइंस अवेलेबल नहीं है. ओनली पीपल हैव वर्क फॉर फ्लैट स्पेसिमेन. सो नाउ इफ समबडी ट्राइज विथ से सिलेंडर, नाउ व्हाट विल हैपन? If it is a box, only surface, top and bottom is open, what will happen? If it is a solid rod, what will happen? If it is a solid square rod, what will happen? If it is a parametric Bezier है, 4 point control में है, या वो एरिया है क्या बोले, बी स्प्लाइन, तो उसमें क्या होगा? क्योंकि आपका सोफा कर्वेज ये है, इसका शेप देखिए, नॉन ज्योमेट्रिकल. सो ज्योमेट्रिकल थिंग्स आर इजी, बट non-geometrical which are created by parametric term in CAD, that's a really dark area. And normally life the components are नॉन ज्योमेट्रिकल। खाली इंजीनियर ही सोचता है कि मेरा मोबाइल रेक्टेंगल होगा और 4 कॉर्नर पे रेडियस होगी, टेबल फ्लैट ही होगा, कोई ऐसा शेप नहीं सोचता है। सो इन रियल वर्ल्ड इफ इट इज अ प्रोडक्ट, देन प्रोडक्ट में हैव वैरायटी इन शेप्स, एंड इफ यू गो फॉर हाउस होल्ड कॉमोडिटी थिंग, आप देखिए कितने शेप से, पहले फ़ोन आते थे, फ़ोन जो घर में रखते थे उसमें कितने शेप आते थे। सो ट्रिमेंडस शेप्स आर अवेलेबल, even utility things are available and you can have n number of shapes. if you want to attract bike body देखिए, उसमें कहाँ geometric shape है, non geometric. So non geometric things are difficult to attack on it, and there is no guideline right now available. So this is a very good area if somebody has a good knowledge of CAD and use of that RE analysis, तो वो जितने लाल पीले डायग्राम है बना सकता है। ठीक है, थैंक यू। इफ एनी क्वेश्चन यू कैन आस्क मी। नहीं, ये देर आर सर्टन मटेरियल विच आर सेंसिबल टू प्रेशर, then you need to take that material. I take that polymer is sensitive to temperature, where I can change its shape at Tg. So that's why I attack on Tg. But there are many materials which are having a sensitivity with different parameters. So that parameters can be taken for this study.
Thank you very much, sir, for the time that you spent.